The first thing you're going to do is put your name and our objective for today. So today I can decompose and compose fractions greater than 1 to express them as a mixed number or an improper fraction using a number line, and we're also going to be using area models. Okay? When you are writing down your objective, if there's any words that you are unsure of, the definitions are here. Okay? Restate what we are learning in your own words. Get it? Got it? Good? All right, read your mathematical practice. Your habits of discussion, the ones I'm looking for today. We're moving on from I agree and disagree with since we've gotten so good at it. But I want to hear you saying what I heard you say was, and then repeat what your partner was telling you. Can you explain this to me? So have your partner explain to you why their area model matches their work in their fraction. And then how did you know your answer was right? So justifying your answer with either your number line or your area model. All right, this is your warm-up for today, similar to yesterday, but a different fraction. What is the fraction shaded? Then write a fraction that is equivalent to the fraction pictured above. And then start your videos. I'm looking for the name of the video, the date, and diligent notes. There's 3 there for you. And then we will meet as a half group, and we'll do an I do, we do, you do. Get it? Got it? Good?
Get it? Got it? Good.
Okay. If you get through your videos before we're ready for half group, you can go ahead and move to collaborative work, and you're going to be working over here. Get it? Got it?
Get it? Got it? Good.
Okay. When I say go, movement, table seats, voice level, 0, participation, Google Classroom, get your slide going, and go. Welcome. Okay, so like we talked about earlier, we're going to be composing and decomposing fractions greater than 1 to express them in various forms. So let's first start off by writing 7/3. Okay, let's close our marker because we're going to talk. All right, first things first, what do you notice about this fraction? Okay.
I noticed that the numerator is greater than the denominator.
Okay, the numerator is greater than the denominator. What else, Omar?
So that tells us it's an improper fraction.
Okay, so the vocabulary term is that it's an improper fraction. What else do we notice and know about this fraction?
We know about this fraction because 7 and thirds supposed to be like the numerator supposed to be small and the denominator supposed to be big.
So what should we do when we see an improper fraction? If this is like an answer, like yesterday when we were multiplying fractions, we were getting a lot of improper fractions as our products, right? So do we leave it this way? What happens? What do we do?
We make it to a mixed number.
A mixed number. What is a mixed number?
A mixed number is a fraction that the denominator is greater than the numerator.
Can you say that again? I want us to decide, do we agree or do we disagree with Jokai? Say it again, a little louder.
What a mixed number is if a denominator is greater than the numerator.
So he's saying that a mixed number is when the denominator is greater than the numerator. Do you agree or disagree, Deschanel? You agree? Well, why do you agree? I'm going to call on Alex B, but listen to what Alex B says, and then I'm going to come back to you, okay? Alex?
I disagree with Jakai because a mixed number is the numerator like smaller and the denominator is bigger, and there's like a whole part. So you gotta so first turn into you gotta divide first. You put 7 over here and 1 over there. You minus that to make it to a mixed number. So.
Oh, don't find the answer yet. We're still just talking about it, okay? Don't jump ahead of me. All right, so you were correct. It's when the denominator is greater than the numerator, but what part were you missing? The whole number. So what's a mixed number?
The whole.
Let's let Deja know. Whole number and what? Okay, so a mixed number is a whole number, but what's it mixed with? What's this? A fraction. And what's important about that fraction?
That is not an improper fraction.
It's not an improper fraction. It's a proper fraction. Okay, so the next step, I agree with all of you. Did a great job. I want you to draw using with bar models 7/3. Let's talk about it. Okay, so who wants to justify their model and why you think it's 7/3?
Well, I think it's 7/3 because I have 7 and I have 1 box, and then the numerator is how many you break it into. So I broke it into 7 and then 3.
And then shaded in 3. So he said the numerator is how many we break it into. Tell me more.
I disagree because the numerator actually tells us how many parts do we have.
How many parts we have, how many are shaded. I'm gonna say that one more time. Okay, so Omar said that our numerator is how many parts need to be shaded. Do you have 7 parts shaded? 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 Okay, so I'm going to write here. Well, we put it in for numerator. All right. How many parts shaded?
7.
So I'll go ahead and put it 7 here.
It looks so familiar.
It looks familiar. So 7's how many parts need to be shaded? What is our denominator?
3.
Our denominator is 3. And what is our denominator supposed to tell us? Tell me more about that.
What is it supposed to be?
Well, I don't know. What do you think? I'm not going to tell you. Let's go back to the denominator. What is the denominator telling us to do?
How many pieces to put?
Tell me more. How many pieces to put what?
How many pieces to break apart?
Oh, what do you mean? How many pieces to break apart?
Like, I want to go back to Jakai because our denominator, so it's like 7 is like the biggest number, and 3 is the part that use the lines like those rectangles to make the number. So
Okay, so we should break it into what? What is that called when our denominator is 3? We need to break it into
thirds.
thirds. Did anyone break theirs into thirds? Okay, so how many parts we break it into? And you guys said because it's 3, it should be thirds. So I'll put thirds. So now that we've talked about it, should we maybe redraw ours? Okay, markers closed real quick. Let's restate what we know. Our numerator is 7. That's how many parts are shaded. Our denominator is 3, so we should break our wholes into thirds. Are we maybe going to have more than 1/3?
Yes.
Okay, go ahead and erase. And I want you to redraw it with our new conversation, with what we discovered. And then I'll have you check yours with mine. Go ahead. Thumbs up when you're done. How many are you going to shade? 7. What do you notice?
That we can't do that.
Why can't we do that?
Because there's only 3 parts and 3 is less than 7.
Okay, so what do you think we should do? Because he said, okay, I drew my thirds and I can't fill in 7. So let's problem solve. What do you think we should do? No, it has to be thirds.
Draw this 7 times.
7 times? I think that would be more than 7 because 7 times 3 is way more than 7. We have way too many parts.
21.
We would have 21 parts. Do we need 21 parts? How many parts do we need?
7.
7. So, what should we do?
You can make 5 parts.
Has to be thirds.
You could make something equal to 7 thirds.
How are we? I agree. We need to make something equal to 7 thirds, but how? How are we going to draw this?
Make another square.
Make another square and do what to it?
To make another third.
And make another group of thirds? All right. Let's try it. See if it works.
Minus.
Can you shade in 7?
No.
Only 6.
We would need 1 more.
Think we need one more? All right, try it. Let's see.
That would be the half. Oh no. Yeah, you would need a half.
Has to be thirds. Do you have thirds on that last one? What do you have?
Thirds.
You have thirds? Count. Check.
1, 2, 3, 4.
You have fourths. All right, thumbs up here. He's done. So go ahead and shade in how many parts? 7. Shade in your 7 parts.
I know.
All right. How many are we going to shade in?
7.
7. Let's quickly shade in 7. All right, we're going to. I promise we're going to talk about it. Just hang on real quick. All right. So what do we notice?
We noticed that there are 3, and we shaded 7. So if we actually can minus the thirds, like 3, it gives us 1/3 and 1 whole. I think it'll give us 2 wholes and a third.
Why?
Because there's 2 wholes and there's a third left over. I disagree with Omar because if it says 3 and since we only have 1, how we're gonna make it to make it into the improper fraction? Because these, if you add these 2, it'll make 2 thirds. And then if you add this one, it'll make 2 wholes and a third.
What do you think?
I do only because you would add those 2 and it would make 2 wholes and 1 third.
Why are these holes?
Because they're all 3 are shaded.
What do you think? Chanel, what do you think? Let's listen. Eyes on her. What I heard Omar and Jakai say is that we have 2 wholes and 1/3. Do you agree or disagree with that? Why?
Because two of the holes are shaded and one of the holes one hose
What would this one be?
third,
1/3. So you said these holes are shaded, and then there is
1/3.
1/3 here. Okay, can I turn over mine now? I now agree with you guys. Okay, so when we have an improper fraction, what we've discovered is we have to have more than one bar model, right? Right? Okay, so because we needed to shade in 7 parts, that doesn't change when what we know about fractions. The numerator is still how many parts is shaded, so we shaded in 7 parts. But our denominator is how many parts we break our area model into, and that was thirds. So we had to just create more thirds until we could shade them all in. But once we did that, you guys are telling me we've created an equivalent fraction because 7/3 ends up being 2 holes and a third. Okay, before we leave, everyone circle 7/3. All right, if I were to make a number bond,
Can we check it?
no, not yet. Okay, we're going to create a number bond to build 7/3. Okay, what would this be if I just had this as an improper
2
fraction? I agree, it would be 2 holes, but what would it be as an improper fraction? How many parts? Count with me.
6.
1, 2, 3, 4, 5, 6. And then what would my denominator be? Yeah, my denominator.
2.
2?
3.
Still thirds. Okay. And then what do we have left?
1/3.
1/3. So when we decompose this, we have 6/3 and 1/3.
Mistaken.
Mhm.
It's look, it's a 6, 7. So it's like from 1, 2, 3. So it's like 5, 6, 7.
So if I added these 6/3 and 1/3, what would it equal?
7.
7/3. All right, y'all go watch your videos. The videos are going to show you how to solve this with number lines in a different way. So try to make that connection. That's going to be your focus, is how is our area models, all right, similar to the number line strategy. Get it, got it, good?
Got it good.
All right, go ahead and go. Rain, Jada, Alex Q, and Jocelyn.